Okay, so now I want to determine the equation of the tangent to something that has a product rule. When x equals 2. So there's a couple of things we're going to do here. Here's your story for the question. We want to complete this. Now we need a point of tangency. And that's going to be given by 2 comma y of 2. And you need your slope of the tangent, which is going to be given by the derivative. And you want it at a particular value. You want it when x equals 2, so that you want the derivative when x equals 2. So let's start off. Let's find our point of tangency. Point of tangency, y equals 2, is going to be 2e squared. So your point of tangency is actually 2 comma 2e squared. That's a point. If you needed to plot it on a graph, you'd take 2.718, you'd square it, and you'd approximate it, and then you'd times it by 2, and you'd approximate it at 14.8. So it would be 2 comma 14.8 approximately. Exactly, it's going to be 2e squared. So now our second step, number 2, find the slope of the tangent, which is equal to the derivative. Well, I'm not using f of x notation. I'm using y notation, so y prime. Now this is a product rule, so it's going to be equal to the derivative of the first, so derivative of x is 1, times the second, e to the x, plus the derivative of the second, e to the x, times the first. I'm going to common factor. I don't have to, I'm noticing as I'm doing this. I could have plugged in directly. Y prime of 2 is going to be e squared. 1 plus 2 is going to be 3e squared. So that is my slope of the tangent. That's exact. I now want to take all of those things and sub it into here. Okay, so we're going to put our y value in and our x value. Here's my slope value. That looks amazing. We're now going to expand. I'm now going to put it in standard form. This is positive, so I leave it alone. I'm going to take the y over to the other side. I'm going to take the negative 2e squared over with the negative 6e squared, so it's going to become positive 2e squared equals 0. And our final answer is 3e squared x's minus 1y and minus 4e squared. And that is what your answer is. That's an equation of a line. That's your a value, negative 1 is your b value, and negative 4e squared is your c value. And that's what life looks like from here on in, kids. Last one, determine the equation of the tangent line to a quotient rule. When x equals negative 2. So again, it's the same story. We're going to want this. So point of tangency. That's the point where the tangent and the curve both touch each other. So it's going to be 2 comma y of 2, which is going to be 2 comma e squared over 4. You're going to want your slope of the tangent, which is f prime. I keep using f prime notation. It's actually y, because it's y, it's not f of x. So it's going to be the derivative of the top times the bottom, subtract the derivative of the bottom times the top, all over the bottom squared. So taking a look at this, and if we plug in x equals 2, I could common factor, but I don't need to. I can plug it in directly, and what I'm going to get is e squared. 2 squared is 4, minus 2 times 2 is 4, e squared, over 2 to the 4. This is 4e squared minus 4e squared over 2 to the 4. I'm leaving it as 2 to the 4 because I see something that's going to happen up here. It's going to be 0 over 2 to the 4, which is simply 0. So my slope of the tangent is 0. What that means is I have a horizontal tangent line. Sorry, I'm off the page. Maybe I should come out a little bit. And so now we're going to plug into our values. So it's going to be y minus, it's e squared over 4 equals slope of the tangent 0, x minus 2. So that's going to be y subtract e squared over 4 equals 0. And it's going to be the line y equals e squared over 4. That is a horizontal line. We think about it for a minute. We can do an x and y axis. We can take our calculator and we can take 2.718. We can square it. We can divide it by 4. It's approximately 1.85. So if we consider this to be 1, if we consider this to be 2, then this would be the line. That would be right about here, which is approximately 1.85. Okay, ladies and gentlemen, there's your homework. Please get started on this, and we're going to keep moving on the weekend. We'll keep moving on Monday once I see you guys.